This is a video to introduce the yenka circuit simulation program. The yenka shortcut is here. It looks like a Y. Double click to run it. Product chooser. Go to the Technology tab and click on the second choice down, Electronics. OK. In this case, we want a new circuit. Over on the left, top choice, click on New. Now here are some of the different elements that can be put into your circuit. First of all, under lab equipment, measurement, let's grab an amp meter. An amp meter measures current going through it. Hold down, drag it over, and this has worked. If it does not work, if the symbol does not look like this, then you may need to zoom in on the work area a little. Hold down the control key and move the wheel on your mouse to zoom in. On this system, it seems to be working okay. During the video, feel free to pause and try to reproduce what I'm doing here. So for the simplest circuit, we need to measure current, how much charge is going through a circuit. We need to measure voltage, the energy per charge of the charges in this circuit. Then over here in our equipment window, we'll scroll down some more, go to electronic components, basic components, and we'll go down to symbolic. That gives us more control over the components. We need a battery to supply energy to the circuit, and a device called a resistor, which is what you'll be studying in the first activity. Then we need to hook these up appropriately. The basic circuit, I'm moving the resistor here just so I can make connections. The basic circuit is going to be the battery and the resistor. If I go over here to the top of the battery, I've got the terminal that I can hold down the mouse. That creates a wire, and I can attach that wire to the top of the resistor. And I can go down to the battery and attach a wire to the resistor. So that's a basic circuit. I haven't measured anything yet. There are two quantities that you will be measuring. One is the voltage, the energy per charge, or more specifically, the electric potential difference between 2 points on the circuit. So a voltmeter has to be connected one end at one point of the circuit, the other end at another point of the circuit, because it measures a difference. So I'll just move it over here. So I want to know the energy difference from one side of the resistor to the other. So one side of the voltmeter, I hold the mouse down, drag over, to one end of the resistor. The other side of the voltmeter, drag down, and now it is measuring the potential difference between the two sides of the resistor, the energy difference, the potential energy difference per charge. And it's reading 9 volts, 9 joules per coulomb. To measure current, we have to do something a little different. We have to take the circuit and actually break it. So I'll click on that wire and I can right click and delete it. So I no longer have a complete circuit. You'll notice the voltmeter is now reading 0. There is no longer any energy difference between here and here. To make things a little easier to read, I'm going to right click on the ammeter, go to properties, and down here I can rotate it so it's oriented horizontally. It just makes life a little easier. Close that. Move it over here just to put it in line. Go on one side of the ammeter, hold the mouse down, drag over here. Still don't have a circuit yet, no current flowing. Go to the other side of the ammeter, drag over here, and now we can see there's current. We have a complete circuit. There is current flowing, and we see voltage. So this is the basic circuit. And you should try connecting this. I'm going to minimize this for a second, or make it smaller, and show you how this circuit would be drawn. So this is how the circuit appears within yenka. Most of these symbols are somewhat standard, but there are a couple of differences for how we usually draw a circuit diagram. So here I'm going to pull up the diagram which shows how this circuit would be drawn. This symbol here is a battery. The long line is the positive side of the battery, and that's similar to what's here, except here they've drawn it a couple of times. An ammeter, indicated here with a circle and the units milliamps, is usually just drawn with an A in it to indicate ammeter, to measure current. The voltmeter, similarly, is a circle with a V in it. The resistor is indicated by a jagged line. So instead of just drawing a little rectangle like yenka does, it's indicated in the diagram by a jagged line. So this is how circuits would be drawn if someone has given it to you, and the translation. So the resistor jagged line is here. The ammeter, circle with an A, is here. The voltmeter, circle with a V, is here. A couple of notes about how these components work. You can change the values of the battery. If you click here, we can change it. So I can backspace over it and change it to, say, a 15 volt. And it immediately makes the adjustment. You'll see the voltmeter now reads 15 volts, and the current has changed correspondingly. Similarly, you can change the value of the resistor. Click over there, and now I can make a 1000 ohm resistor if I want. So you do have control over the value of the components. Some things that don't work. For instance, if I select this wire and delete it, I no longer have a complete circuit. You'll notice that the units here change to the smallest size units, microamps and microvolts. That's called auto ranging. The meters will automatically try to use the smallest unit that will give you a number. Okay, so let's put that wire back. So we have 15 milliamps. If I right click on the ammeter and do properties, here's where we see that the auto range has been selected, so it would automatically choose units. If somehow that is not selected, then it's going to do something that's less convenient, and it's a reading that's not as accurate. So the current is actually 15 milliamps, but it's only showing 2 digits and it's trying to show it as amps. So use auto ranging, and if the numbers look too small for some reason, check that you actually do have auto ranging. By the same token, if I click here on the resistor, if I click on the units, I can automatically change it to a larger resistance just by choosing mega ohms, 1000 ohms. And you see now the current has decreased correspondingly. Now if I turn off auto ranging, it can't even read it because it's trying to use the amp scale. So if you see a reading of 0, check auto ranging. That may be one possibility of what's wrong. Another possibility, as I showed before, is that you don't have a complete circuit. Again, if I took rid of this wire, again, there's nothing to read. Okay, so I'll put this back now. So that's the basics of setting up yenka. At some point when you've got a circuit, you may want to save it. You can save by going down here and clicking on the little floppy disk symbol. And you can decide where you're going to save it and give it a name. First circuit. And so now this will show up on my desktop somewhere. First circuit. Now if I left yenka, I may say, oh, I can go back to my first circuit and work on it by double clicking on it. And that works for most programs. Most programs that create a file, you can double click on the file. And in this case, it actually worked. I can tell you though that it will not work on every computer. I'm running an older version of Windows on this computer. Windows 7, I think. I know that when it's been tried on some Windows 10 computers, that didn't work. When you double clicked, it did not actually open up the circuit. So if you double click and it works, that's great. But if it just spins its wheels, then you have to actually start yenka. Technology, electronics, click on OK. And now, instead of clicking on New, click on Open Local. And you can tell it where to look. I, again, will look on the desktop. Scroll down, and there is my first circuit. Okay, so to illustrate a couple of issues regarding how to use ammeters and voltmeters, and to give you a little practice, I'm going to put up a couple of other circuits here. You can pause the video, go into yenka, try to reproduce each one, do them in order, and then you can start the video again and I'll show you what it should look like and what happens, because it illustrates a couple of the pitfalls of using these meters. Normally in a lab, there's certain things we would tell you just not to do because they could damage the meters. The nice thing with yenka is you can actually set up those conditions and see what happens if you actually did them without actually damaging a meter. Okay, so I'm going to click on the yenka symbol here, click on New, and it's ready to do a new circuit. This is the diagrams I showed you before. First, try to set up circuit 2. It's the same as the previous circuit. The only difference is instead of a voltmeter hooked up across the resistor, we're going to hook up an ammeter across the resistor. So try to set up that circuit, pause the video, and then I will show you how it's set up. Okay, so I'm going to maximize this for now so I've got lots of space. So we need a battery, we need a resistor, and I'll scroll back up here to lab equipment measurement and I'll bring out 2 ammeters. So the first ammeter, I will hook it up the proper way. I'll do properties and rotate it to make it a little easier to visualize. And the proper way of an ammeter, again, is you hook up the wire to one end and hook up the other end to where the current is going. So the proper way is the current is forced to go through the meter, and the meter measures the current going through it. And let us know on the other end, complete the circuit. So all the current is forced to go through the meter, and the meter measures the current through it. This would be what's called a series arrangement. The meter is in series with the resistor. The current goes through here, and then all goes through here. The other arrangement would be what's called a parallel arrangement. We hook one end of the meter on one side of the resistor, and the other end of the meter on the other side of the resistor. When I make this connection, there will now be 2 paths. The path splits. I guess just leave that there for now. The path is going to split here. There'll be one path this way and another path this way through the meter to this point after I make the connection. So that's called a parallel arrangement where you have 2 paths. So let's hook this up here. So this is how not to hook up an ammeter, and here's why. These little symbols mean you had what's called a short circuit. A short circuit basically means you have connected points that are at different potentials, different voltages, different energy per charge through a path that has no resistance. So basically charge can flow without limit, and that's not good. In the real lab, you could have blown out the meter or blown a fuse. In your house, a short circuit could actually start a fire. So, an ammeter does not want to be in parallel. It should never be in parallel with components. It should always be in series with the components, so that all the current flowing through the ammeter flows through another component. We are therefore measuring the current going through that component. It's designed to not resist the flow of current. So if you put it in parallel, it's going to create an alternate path, and all the current will go there, and boom. Okay, so that's one thing to remember about the ammeter. It always goes in series, never in parallel. Okay, I'll do new. I'm not going to save this. You may want to save yours. Okay, here's the next bad circuit I want you to try to implement. Having the battery and the ammeter, the resistor, and the voltmeter all in the series arrangement where the current goes through one, and then the other, and then the other. So pause the video, try to set that up, and we'll look at it. Okay, so I need an ammeter, a voltmeter. I'll go ahead, properties, and rotate each one of them just so they look nice in the circuit. Scroll down here to electronic components, basic components, symbolic, and I need a battery and a resistor. And we click on the top of the battery, drag a wire over here, the other end of the ammeter, and here. So the ammeter is in series with the resistor as proper to measure the current through the resistor. And connect up the voltmeter at each end. And you'll see the voltmeter is reading negative because this little black square is indicating the positive end of the voltmeter. So I actually have the voltmeter hooked up backwards in comparison to this battery. But the main thing is my ammeter is not reading any current. If we look at circuit 1, you'll see the voltmeter was in parallel with the resistor. One end was connected to one end of the resistor, the other to the other end. That's how a voltmeter works. It needs to be in parallel because it's measuring a difference between 2 points. Importantly, the voltmeter does not let current through. So remember when we had the ammeter here, it let lots of current through and everything blew up. The voltmeter is designed not to do that. It's designed not to give the current an alternate path. So a voltmeter is designed to not let current through. So those are a couple of things that could go wrong and a couple of the causes. One, putting an ammeter in parallel across the components, or in other words, not putting it in series, and then you've created a short circuit and things blow up. Two, making a voltmeter part of the actual circuit, in which case the voltmeter is going to block the circuit and you see no current whatsoever. And this is your first introduction. You'll be working with these circuits for a while, so it's okay if things don't go well at first. But if you do have a circuit that's not working, you can save it and then send the file to your instructor, and your instructor will be able to advise you on it without, again, harming any of the equipment. And this is the end of the video.